Hey guys, today we're going to be deriving the derivative of tangent. Now, I don't want to use the definition of derivative. It's a bit long, it's a bit tedious, but I also understand that many people might end up forgetting what the derivative of something like tangent is. So, in order to find this derivative, we are going to need a couple of things. We're going to need to know what the derivative of sine is. The derivative of sine of x is cosine. We're going to need to know what the derivative of cosine is. The derivative of cosine is negative sine. So if we're taking the derivative of one function divided by another function, the formula for its derivative is ho d high, the derivative of the top multiplied by the bottom, minus high d ho, all over ho ho. Okay, so in using these three derivatives, as well as a trigonometric identity, which is that tangent of x is equal to sine of x over cosine of x, we're going to take the derivative of tangent. Okay, so starting with this identity, we have the derivative of sine of x over cosine of x. And then using the quotient rule, we have the bottom, cosine of x, times the derivative of the top, which is cosine of x, minus the top, sine of x, times the derivative of the bottom. Derivative of cosine of x is negative sine of x. Negative sine of x, all over the bottom multiplied by itself. So we have cosine squared of x. So this is our derivative. Of course, we need to simplify, so we have cosine squared of x minus sine of x times negative sine of x, so plus sine squared of x all over cosine squared. Cosine squared plus sine squared is 1. 1 over cosine squared of x. You still definitely need your trig properties here. 1 over cosine is secant. So 1 over cosine squared would be secant squared. So that's the derivative of tangent. I hope you figured out a new way to derive that. And if you were to get lost on an exam, you can use this method to derive the derivative for yourself.